Hello everyone, welcome back. In this section we'll be talking about if-else statements in our Python program. This if-else statement controls decision making in our program, and we will be demonstrating how you can use this statement in different form in your programs. Let's go straight to Jupyter Editor to demonstrate use of if-else statement. So in my Jupyter Editor I have a new script opened. So I will start with random module. Let's import randint from random module, and what's the random? So the spelling of random is wrong, so that's random randint imported. So let's create a number variable num that takes random integer between 1 to 10, and we now ask a user to guess the value of what the random integer is. So let's say enter your guess. So and okay, so enter your guess, and if the guess is equal to the random number, then we'll print you got it. So let's run this and see what the output looks like. Okay, we are missing what else that we're missing. Is not random, it's the randint that we have here, randint. So that's fine, now we get it right. So if I guess that the random number is 5, let's see, I got it. Wow, that's interesting. So the random number here that is created is 5, and I entered 5 and it said you got it. I will be a good that will be interesting, assuming that's a jackpot to win. So let's try the code again, and if I guess the number now is 7, yeah, it doesn't do anything, and that means I didn't get the number right. So we said if the guess is equal to the number, then print you got it. We didn't say anything that will happen assuming the guess is not correct. You can see in the last example I got my guess was 5, and the random integer was also 5. So now my guess is 7 and the random integer is in 7. So if the guess is equal to, it is not, so it doesn't print you got it. So we need to capture the fact when the guess is not correct, and that situation is else. That means if the guess is not equal to this, what should I do? Print your guess is wrong, and let's say the number is no. So let's now try this again. Let me guess 5. My guess is wrong, the number is 4. So we are able to capture when the user's guess is not equal to the number. My guess is wrong, the number is 1. And you can see now that, yeah, my guess is wrong, the number is 8. So we are able to capture when the user guess is wrong with the else statement. So if the user guess is equal to the number, then print you got it. Else, print your guess is wrong, the number is this. So that's the simple example of the structure of the if-else statement. Let's look at kind of a bigger picture of what we can use if-else statement to do. So let's look at a more practical example. Let's say we want to write a code that converts percentage grade to percentage score to grade. Assuming you have a percentage that is greater than or equals to 95, the grade will be A1, and the percentage less than 95 but greater than or equals to 89, the grade will be A2, and as it goes like that down. So we want to write the code that automatically gives us our grade if the user enters a percentage score. So before we write the code, I want to introduce you to these operators we have that we use in conditional statements. If else statements are called conditional statements. So we use comparison operators and logical operators. Comparison operators is used to compare between two values, and the output will be either true or false, and sometimes we will need to combine one or more comparison test, and we use logical operator to do this combination. So let's go back to the code that we want to write, which will convert percentage score of user to the grade. So let me copy this code down. So here we take from the user the score, their percentage score, and the first statement say if your score is greater than or equals to 95, then the grade is A1. The second one says if the score is less than 95. Now the score is less than 95 and the score is greater than or equals to 89. So that two conditions must be correct, must be true for your grade to be equals to A2. So your score will be less than 95 and it should be greater than or equals to 89. That goes down to next one, which says your score will be less than 89 and your score should be greater than or equals to 83 for you to have A3. So this is the if else statement that tests each of the score and assign the corresponding grade. And if we run this code now, it will ask the user to enter the percentage score. Let's say I entered 67, which is B1. If I enter say 98, that gives me A1. Assuming I enter 47, that gives me D1. Let's say I enter 42, that will be D3. And for a value below 20, let's say 15, that will be bad failure. That is another example of use of if else statement. That's an example of if statements. Now we don't have else here. And before I go to including something else to this code and make it more efficient, I want to show you the common mistakes that people make in conditional statements. Common mistakes. One common mistake is if you want to test x is equal to 1. If x is equal to 1, this is a wrong statement. I said the other time that comparison operator for equality is a double equal sign, not single one. The first one is assigning 1 to x, but the second one is actually testing if this one is actually testing if x is equal to 1. So that's a common mistake. And another mistake that people often make is wrong logic. For example, if we want to test if x is between 1 and 100, let's say if x is greater than 1 or x is less than 100, we want to ensure that x is between 1 and 100. So print value of x is between 1 and 100, and this will, okay, we are missing So this will print value of x is between 1 and 100, which is wrong because the value of x is below 1. So what we should do here is to check this and this, because if you check this right, the value of x is not greater than 1, so this is false. But we use all logical operator, and we now check if x is less than 100, which is true. X is less than 100. So for all logical operator, if either of these comparison is true, the output would be true, and if the output is true, this will be printed. So instead of using this or, we need to use and in this case to make sure that only when the two comparison, this and this, is true, that is when the output will be printed. So we can do this. If you run this now, you know the output is not printed because this value is not within 1 and 100. If you remove this negative sign and you print, you can see that this x is between 1 and 100. So that's logical mistake is common when you are using when you are writing programs that involves conditional statements. So let's make this code more efficient. I'm copying it out now. Let's make this code more efficient by using another construct of conditional statements. So instead of testing if, this if statement tests each of these if constructs. So if you have the score 98, so you will say 98 is greater than or equals to 95, which is yes, it prints. But the program keeps on testing each of these again. It tests if 98 is less than 95, no. It tests if 90 and 98 is greater than 95, yes. This is yes, but this is no. That means when we use and of this, then this will not be printed, because the total, if this is true and this is false and we use and, the output will be false. The output will be false. So it tests each of these to be false. That's why we only have 98, and that's why we only have the first one. Sorry, if I enter this, that's why we only have your grade is A1 printed. If we put all here, if we put all here instead of and we put 98, it will print your grade is A1 and your grade is A2, because this also outputs to be true, because it tests if 98 is less than 95, which is not true, which is false, and it tests if 98 is greater than 89, which is true. 98 is greater than 8 or equals to 89 is true, and because we have all statements here, this is false and this is true, the output will be true, so this will be printed. So instead of or, we should have and here to make sure that these two statements has to be true before the print statement is implemented. So but what I want to show you here is to make this one more efficient by using else if. Else if is called elif here. Else if we make sure that only the one that gets the condition true is, and if one has gotten the condition true, the others will not be executed, will not be tested again. Let's write the elif statement. What this does is like the if else statement. If this is true, do this, else do this. So if the first test is true, then the else test will not be needed anymore. So instead of if single if, then we use elif. The first one is if, all the others is elif, and the last one will be else. So else, if you have tested all the one in front, then we don't need to use this condition again. We just use else. Else, any other thing will fall between this range, within this range, and it will print bad failure. So if we run this, it's almost the same thing. If I say 98 gives me A, if I say 40 it gives me the D3, if I say 51 is my score, it gives me C3. So what happens there is that if I put 51, it tests if this is true. 51 is greater than or equals to 95. No. 51 is less than 95. Yes. 51 is greater than 89. No. And yes and no will give you no. 51 is less than 89. Yes. 51 is greater than 83. No. Then for true and false we give you false. So 51 is less than 83. Yes. 51 is greater than 70, greater than or equals to 76. No. So this is true, this is false. True and false we give you output of false. So 51 is less than 76. Yes. 51 is greater than 70. No. So this is true and false. True and false will give you false. 51 is less than 70. Yes. 51 is greater than 67. No. Then true and false will give you false. So those ones will not be executed. 51 is less than 67. Yes. 51 is greater than 64. No. This one also will output false. This will not be printed. So 51 is less than 64. Yes. 51 is greater than 60. No. This one also will output false, and this will not be printed. 51 is less than 60. Yes. 51 is greater than 57. No. This one will also output false, so this will not be printed. 51 is greater than is less than 57. Yes. 51 is greater than 54. No. This will also yield false, and this will not be printed. 51 is less than 54. Yes. 51 is greater than 50. Yes. So this will be printed. Immediately this is printed, all others will not be tested, and we will get out of the else if else loop. So that is why when you put 51, it will only give you your score is C3. So we can make this more efficient by removing the false part of the logical comparison. So we don't need this again, because if 95, if you have anything less than 95, assuming you have 94, 94 will be tested. No, it is not greater than 95. It comes here, it checks if 94 is less than 95. It's that this is true, and it checks if 94 is greater than 89, which is true. It will print this, but it doesn't need to check this anymore, because if it prints, if we have 98 that is greater than 95, it prints this one. If it has to test this also, 98 is also greater than 89, it would print this. But because we have used else if, it doesn't have to test the remaining again. Since this is true, all others will be ignored. So we don't need this anymore. We don't need this first comparison test anymore. So it reduces our code. So it reduces our code. So we can take this away. Take this away. We can take this away. We can take this away. So can take this away. Gives us the same output. Yes, and if we run it again and we have 98 gives us the A1, and we have 51 gives us the C3. Just to let you know that taking that away is because we have used else if. If we take it away here, take the first part away here, where we have single if statement and we say our score is 98, it prints your grade is A and your grade is A2, because it tests this. Our score is 98, is greater than 95. It prints this, which is true, and prints this, and come back to test. Our score is 98, is greater than or equals to 89, which is also true, and it prints this again. So it tests all the if statement. But in the other case, when we use elif, immediately one is true, the subsequent one will be ignored, and that is why it works the same way after removing the first part of the comparison. So that's an example of more efficient use of else if instead of using single if statement or true. So I've shown you now that if you have a logical operator false, and false, will be equal to false. False and true will be equals to false. Then true and false will be equals to false. Only time you have and logical operator yielding a true is when both sides are true, or all the combinations are true. So for all operator, if you have false or false, the output will be false. If you have false or true, the output will be true. If you have true or false, the output will be true. And if you have true, this is true. If you have true or true, the output will be true. So whenever you have one of these combination to be true with OR operator, then you will have the output to be true. You can combine more than one, like you can say true or true and false. So this, you know that this and or this will give you true, but when you do true and false, it will give you false. So this true false is like a condition. If we say if 2 is equal to 1, you know that 2 is not equals to 1. 2 is not equals to 1. So and let's say if 2 is equal to 1 or 3 is greater than 4, print the output is true. You can see that 2 is not equal to 1, so this is false. Or 3, let's say this is 4 is greater than 3, or 4 is greater than 3, which is true. So this is false or true. So the output here will be true. If you run this, it will tell you the output is true. You understand? So but if you say this 2 is greater than 2 is equal to 1, which is not true, 4 is less than 3, which is not true, it will not print anything. So that's an example of true, false, false that I gave you the other time. Then let's assume we want to get the number of multiples of 12 that we have. Let's say we want to get the number of multiples of 12 that we have between 1 to 1000. So we have something like, let's create a variable that will take those number multiples. Let's say count, which is equal to 0 initially, and we say for integer that range in range 1 to 1000. So 1 to 1000 will be 1001. So, and how do we get the multiple of 12? If I modulo 12 is equal to 0, so that's how to get multiple of 12. Whatever you divide by 12 and returns a 0 remainder is a multiple of 12. So if we have any value that is modulo of 12 and it gives us 0 is a multiple of 12, then you now increase the count. You increase the count. So this code is the same thing as saying count is equal to count plus 1. So this is a short form of this. So we increase the count, and that's all. Note, you say print number of multiple of 12 between 1 to 1000 say count. So if you run this now, it gives you number of multiple of 12 between 1 to 1000, which is 83. So we can have multiple of 12 that is 83 between 1 to 1000. We can actually print those multiple of 12 that we have. Let's say print I. So you can see them. Between 1 to 1000, we have the following numbers that are multiples of 12. So 83 in number. 83 in number. So one thing I want to show you here is that indentation matters. If we want to print the multiple of 12 after the whole iteration within the for loop has been carried out, you can see where the indentation of the print is. If you put the print here, it will be printing the multiple of 12 at each iteration of the for loop. Let's look at it. Can you see? So all the time he has not even gotten multiple of 12. Can you see how he's printing them as? So to get the correct output, you need to have the loop out of the, as in the print out of the for loop, and the count also is out of the for loop. If you put the count here inside the for loop, anytime the iteration is created, the count is 0 is reassigned to the count, and at the end of the day you will see that the count will only be equals to 1. The count will only be equals to and even we cannot even get the count from here. Let me see. The count will be equals to 0 because the for loop is always assigning 0 to the count. So make sure you put the count outside the for loop so it adds to it as the for loop iterates. So if we add more 0 and we are looking for from 1 to 10,000, you can see then we have 833. This looks like a pattern. If we have more 0, let's see what we have. We have 8,333 multiples of 12. So that is a good example to show you the concept of indentation here. The concept of indentation here, and where the count reside actually matters. Where the count reside actually matters. Let me give another example to show this positioning. Let's compare these two codes. Let's compare these two codes in the for loop. So we use the random int again. So we have the first one that said random int not 1. It takes a random integer between 1 and 10, and the second and the for loop now goes between 0 and 5 to print a multiplied by the random number. The same here, but the difference is that the random number now is created within the for loop. If you run this code now, you will see, let's see the output. You can see the first loop, the output numbers of a is the same. Number of a is the same because the random integer is being created here and is now used inside the for loop. So whatever is taken here is the same throughout the iteration of the for loop, but in the second case the random number is created inside the for loop, and every iteration of the for loop creates a different value for the random number that is multiplied by here. So that's why you have different numbers of a for each iteration of the for loop here, for each iteration of the for loop in the second output. So we can see how the position of this random integer actually changes the number of the output of the two codes. So remember, indentation matters to Python interpreter, and it determines what your output will be. So before I go, I will show you this. I will give you this test. Write a code that will create this multiplication table from 1 to 12, and you can see that 1 multiplied by 2 times 1 is 2, 2 times 2 4, 2 times 3 6, that goes down to 24, 3 times 1 3, 3 times 2, so you can see till it gets to 12 times 1 is 12, 12 times 2, 24, is 12 times 12 is 144. We can use for loop and if statement to actually create this multiplication table design. So I want you to try. In the next session I'll give you the answer for this, the code that I used to create this, and you might even have a more efficient code. Note that the spacing, and there are some you can search for ways to space and make it like a good table, as it is shown in this example. So next section we will be talking about another very important concept in programming, which is about string data type. We'll be exploring more about string data type. We have used string in some of our programs. String data type are text values, variables that store text values. So we'll be exploring different ways you can manipulate strings in your program, and this will be interesting thing to know, which will be very useful to your code and your programming construct. So till then, this is the end of this section. Next we'll go into strings and manipulation of string data type.